Good day, wonderful students. It's chemistry class once again, and we started with alkanes, introduction to organic chemistry. Last class we treated alkanes. Don't forget we looked at methane. We studied methane extensively, and we looked at the preparation of methane, its chemical properties, that is, its ability to undergo combustion reaction and substitution reaction. And I explained to you what homologous series is all about, characteristics of homologous series. I told you why we have numerous organic compounds and the properties of organic compounds. Now, we want to learn today how to name alkanes, that is, IUPAC nomenclature of alkanes. In naming alkanes, there are some certain rules we must abide to, and we shall be looking at the different forms of alkanes we have. The first slide talked about straight chain alkanes. Alkane can be straight chain, it can be branched, and it can be in cyclic form. So when you are dealing with an unbranched alkanes, that is straight chain alkanes, how do you name them? Now, the basic thing for you here is to understand the rules. When you understand the rules, it's gonna be a walk in the park for you. Now, the first rule here is this: you have to indicate the number of carbon atoms in the chain with prefix followed by the name ending. What I'm trying to say is this. Look at this. You know, the table I gave you last class, I told you that when you are dealing with a 1 carbon alkanes, the prefix is met, that is methane. 2 carbon is ethane, 3 carbon is propane, 4 carbon is butane. You have to understand this because it's very important. Now, for alkanes that are beyond butane, that is when the carbon atom is from 5 and above, you make use of your Greek root. You are familiar with your polygon, so you start with pentane. For 6, x, from the word hexagon, hexane. The Greek root for 7 is heptane. For 8 is octane. For 9 is nonane. And for 10 is decane. For 11 is undecane, 12 dodecane, tridecane. For 20 icosane. But what we are concerned about now is the first 10 alkane, first 10 members of the alkanes. So once you understand the parent name, that's the first thing for you to know. Understand the parent name offhand. For example, look at ethane. Now, how do you draw the structure? You already know the general formula, that is CnH2n plus 2. You know that your ethane is C2H6. C2H6. Now, if you look at this structure of ethane, you draw carbon. Your carbon bonded with another carbon. Now, there is something you must understand, that carbon is tetravalent. I come again. Carbon is tetravalent. What does that mean? Carbon can be surrounded by 4 bonds. Only 4 bonds. It must not exceed 4, and it must not be lesser than 4 in organic chemistry. Now, any structure you draw, you must put this condition in perspective, that carbon is tetravalent. So the first carbon, let's count the number of bonds around it. 1, 2, 3, 4. The second carbon, 1, 2, 3, 4. So any structure you draw, you must put this in mind. So ethane is C2H6. So this is the first carbon, second carbon, surrounded by 6 hydrogen. For propane is C3H8. You get that from your general molecular formula, CnH2n plus 2. So putting in consideration that alkanes are saturated hydrocarbons, no double bond. Everything surrounding the carbon must be single bond. So you see 1, 2, 3, 4, 5, 6, 7, 8. So for butane is C4H10. The carbon is 4, 1, 2, 3, 4, surrounded by 10 hydrogen. If you count the number of hydrogen, it's 10. So for straight chain hydrocarbon it is that simple. For straight chain hydrocarbon, it is that simple. Once you understand the parent name and you understand that for your carbon they must be surrounded by 4 bonds. 4 bonds. So that is that. So let's look at the branch, how to name branch chain. You have to listen here. You have to listen because there are a lot of rules to apply here. Now, when you are naming a branch chain, let's quickly go through the rules. Number 1 is identify the longest chain of carbon atom. That is the parent chain, because that provides you the root name. Then number 2 is that when there are 2 or more parent chain of identical length, choose the parent chain with the greater number of substituents. You will understand this better when we treat this example. Number 3 is identify the name of the substituent, number the parent chain, then one substituent, then number from one end that give the substituent the lowest possible number. Now, to give this story meaning, let's consider this example. Look at this. Look at this. Coming, trying to make it easier for you to see. Okay, we are there. Now, look at this compound. You have to first identify that it is branched. Why did I call it branched? We have straight chain here and we have an attachment. Because of this attachment, that's what makes it a branched chain. Unlike the other ones we've considered, nothing branched. Now, having known that this is a branched alkane, so the first thing we have to do is to number. Now, numbering can be done from left to right or from right to left. Now, let's look at the first numbering. The first numbering is 1, 2, up to 6. Now, the substituent which makes the alkane branched is CH3, and CH3 is methyl. I explained alkyl group the other time for you that every alkane has a corresponding alkyl group. For methane, which is CH4, is alkyl derivative is methyl. Methyl is gotten from methane. Methane is CH4. So when you remove one hydrogen, it becomes CH3, and that CH3 will now be methyl. For ethane, ethane is C2H6. If you remove one hydrogen from C2H6, you will have C2H5, which is ethyl. For the last, propane is C3H10, C3H8. So its alkyl correspondence is C3H7. So you have to understand your alkyl group, your alkyl group. So this is methyl, and going by this numbering, we number 1, 2, up to 6. Now, you now ask yourself, alkane with 6 carbon is what? Is hexane. So that's the first thing you have to understand. Hexane. So the parent carbon, which is this, is hexane. So you now consider your substituent. Your substituent is methyl. You ask yourself, on what carbon? Is on this carbon, carbon 3. So the name here is 3-methyl-hexane. You talk about the substituent first before you now put the parent chain. You name the substituent 3-methyl. Why 3? 3 because it is on carbon 3. And methyl, which is the substituent. You would notice an hyphen between the 3 and the M. In naming organic compound, you don't muddle things up. The rule is that when you are writing a number and you want to write an alphabet, an hyphen is needed to separate them. So you have 3-methyl-hexane. I hope that is clear. Now, here we are told this is terminal carbon. Yes, any carbon at the end, it is called the terminal carbon. This is a terminal carbon here. I hope that is clear. Now, someone else could have numbered this thing, numbered it differently. Look at it. Someone else could have said, okay, I want to number mine from left to right. This was done from right to left. Now let's look at, if the numbering is from right to left. Now look up. From left to right. We have 1, 2, 3, 4, 5, 6. Now with this numbering now, our methyl group is no longer on carbon 3 as it was here. It is now on carbon 4. Then we term this numbering wrong. Wrong because it does not give your substituent the lowest possible number. So you go with the numbering that will give your substituent lower number. So this numbering is the most appropriate because it gives our substituent methyl 3, while this gives the substituent 4. So this is wrong. So if I give you this, if you are given this in an exam and you name it as 4-methyl-hexane, you are wrong because you did not put the rule into perspective. So you have to be very careful when you are numbering. Number from left to right, number from right to left, then choose wisely. The one that gives your substituent the lowest possible number is what you should follow. I hope that is clear. Now let's look at other examples. Okay, let's look at other examples. Now, in this case now, we are getting a more complex branched alkanes. Another rule here says if you have 2 or more identical substituents, what do? Number from the end that gives the lower number to the substituent encountered first. In this case now, we are having more than one substituent. So you are having more than 2 substituents. You number from the side that gives your first substituent the lowest possible number. Then the number of times the substituent occur is indicated by the prefix di, tri, tetra, penta, hexa. That is, it is very possible that in a compound you have the substituent appearing twice, thrice, 4 times, 5 times. So you use the word di, tri, tetra, penta, hexa. You understand it better when I treat this example. Now another rule says when you have 2 or more substituents, you must name them alphabetically from the end that gives the lower number to the substituent encountered. Now let's consider this example. Good. Look at this. Don't forget, you have to start observing the rule from rule 1. This is the compound we are to name now. Now the first thing to do, number. Now the numbering done is from right to left, from 1 to 8. It is, if you number from 8 to 1, it will give you a different name. This was adopted because it has been found that this is the correct numbering. Now taking this as our correct numbering, now we have numbered. Then the parent alkane is up to 8. That's octane. So that's the root name, octane. That's our parent alkane, is octane because it's from carbon 1 to 8. So that is settled. Now then we'll settle the substituent. If you look at the first substituent, is methyl CH3, is on carbon 2. Another methyl is on carbon 3. Then you have, this is not methyl, this is ethyl. How do I know? If you count everything together, it's C2H5. 1, 2, C2, then 2, 3, C2H5. This is another substituent, ethyl. You have to be conversant with this substituent. You have methyl, ethyl, propyl. So that's settled. Then you now have another methyl on carbon 7. Now, what do? Now we have 2 types of substituents, methyl and ethyl. Now, with these 2 substituents now, which one should come first alphabetically? That's X. E comes before M. don't consider this tri or di or whatever. What you are considering is the name of the substituent, not the prefix di, tri, whatever. Because we want to consider the prefix. If it was to be di, you would have said di will come first. But we only consider the name of the substituent. So alphabetically, E comes before M. Now, the ethyl is on carbon number 5. So you say 5-ethyl. Don't forget your hyphen separate your number and your alphabet. 5-ethyl. Then you start with the methyl. The first one is on carbon 2. The second one is on carbon 3. And the last one is on carbon 7. So you say another hyphen number 2, 3, 7. Because we now have 3 methyl, you say trimethyl, then the parent alkane, octane. 5-ethyl, 2, 3, 7, trimethyl, methyl, octane. Remember, look at this. The numbers are separated by commas. So you separate numbers by comma, you separate numbers and letter by hyphen. Don't ever muddle things up. So this is 5-ethyl by virtue of alphabetical numbering. 5-ethyl, 2, 3, 7, trimethyl octane. So that is settled. Now let's look at another example here. This is another branched hydrocarbon with different substituents. So this numbering from left to right is done. Now that this is used and is giving us the correct answer doesn't mean it must always be from left. You can see this one was from right to left, while this one is from left to right. So no strict rules. Okay, I think this is what we are considering. Okay, good. No strict rules. Treat the question as it comes. So this is from carbon 1 to carbon 5. Now, what are the substituents? We have an ethyl here, but the first substituent is methyl, another methyl here. So going by your alphabet, the parent hydrocarbon is 5. That's pentane. That's it, pentane. So numbering, because ethyl should come first alphabetically. So you say 3-ethyl, 3 because it is on carbon 3. This is the first carbon, this is the second carbon, this is the third carbon, and the ethyl is on carbon 3. That's why we have it as 3-ethyl. Then you move to the methyl. The first one is on carbon 2, the second one is on carbon 3. So you do 2, 3, because there are 2, you use the prefix di. 2, 3 dimethyl pentane. I hope that is clear. So let's look at, this is a tougher example. Just take it easy, you will get it. Just follow me, you will get it. It's not as tough as it is. So look at this. You may be faced with this kind of structure. There's nothing difficult there. Now what we have here is a bit different from what we've been having. Our numbering has always been left to right or right to left, but in this case it is not like that, because if you look at the structure, you can go this way: 1, 2, 3, 4, 5, from 1 to 7. It gives you 7. And at the same time, if you can go this way too: 1, 2, 3, 4, 5, 6, 7. That's another possibility. That is another possibility. So if you are going from left to right without doing any branching, it means that this whole structure here will be perceived as substituent. This will be seen as substituent, this will be seen as substituent, this will be seen as substituent. But if you go this way, because both numbering gives us 7, 7. Parents, no one is longer than each other. So if you go this way, if you go from here to here, it means everything here will be seen as substituent. Everything here will be seen, everything from this place to this place will be seen as substituent, and everything, this one too will be seen as substituent, this one will be seen as substituent. Now let's look at the answer. Now the answer is this numbering from 1 to 7 is the correct one. Why? Because of the number that the substituents have at the end of the naming. Look at it. We are taking this numbering to be the right numbering from right to left. So it means that our first substituent is methyl 2, second one is another methyl 3, and the third one is another methyl 5. That is 2,3,5 trimethyl. Don't forget our parent chain is 7, which is heptane. Then I told you that everything here will be seen as substituent. Now, what is the name of this substituent? 1, 2, 3, C3H322, that's 7, C3H7, that is propyl. That is propyl. So you can see your alkyl are very important. So it means we have 2, 3, 5 trimethyl. Then the propyl is on carbon 4 propyl heptane. Now this is wrong because if you look at this, it gives us 2,3-dimethyl-4-butyl. You see, we are having substituent that is but. So this is wrong. This is more correct than this because of the numbering that this gives us. Because of the numbering, this gives the substituent. So you can try this. While we move ahead. Now, there are some alkanes called haloalkanes. Halo from the word halogen. Your chlorine, fluorine, bromine, and iodine. At times, alkane we have this halogen as a substituent. Now, when you have fluorine on your alkane, you don't call it fluorine. The names become fluoro. Chlorine becomes chloro. Bromine becomes bromo, and iodine becomes iodo. So let's look at an example. Now the rule is that just like alkyl substituent, just like your methyl, propyl, butyl, the halogens are placed at the beginning of the name and are ordered alphabetically. They are ordered alphabetically. Now let's look at this example. The first one. The first thing is to name your parent hydrocarbon. 1, we are numbering from 1, 2, 3. This is the longest chain. The longest chain will give you the parent hydrocarbon. 1, 2, 3 is the longest chain. So if we do that, it means our parent chain is propane because it is 1, 2, 3. Propane. Now let's look at the substituent. We have substituent here. CH3 is methyl. We've established that. And this is chlorine as a substituent. So we call it chloro. So in naming it, you name your halogen first. 2-chloro. Because your methyl 2 is on carbon 2. 2-methyl. Coming. Okay. 2-chloro, 2-methyl propane. It's as simple as that. Let's look at the second one. Let's look at our parent carbon. 1, 2, 3, 4, 5. That is pentane. Then let's look at our substituent. We have chlorine on carbon 2, methyl on carbon 2, another methyl on carbon 3. So it is named 2-chloro, 2,3-dimethyl. Don't say 2-methyl, 3-methyl. No. We don't. Once the substituent is the same, once it is the same substituent, you don't give them name individually by saying 2-methyl. You now say another 3-methyl. No. You use your prefix di. That is 2,3-dimethyl pentane. I I hope you are getting this thing. Let's look at the last one. We have 1, 2, 3. Our parent chain is propane, and the first chlorine is on carbon 1, that is 1 chloro, and the second and third group, which is methyl group, they are on carbon number 2. So we have 1, 2, 3. Okay, the numbering is from here: 1, 2, 3. So if the numbering is 1, 2, 3, it means our chlorine is on carbon 1 and our methyl is on carbon 2. Okay. The numbering is this: 1, 2, 3. The numbering is 1, 2, 3. 1, 2, 3. Oh, something is wrong with this naming. Should have been 2,2-dimethyl-propane, because this is the carbon that is carrying the 2-methyl group, and one is here, another one is here. So both methyl group are on the same carbon. Because they are on the same carbon, it should have been 2,2-dimethyl-propane. 2,2-dimethyl-propane, not 2,3, because both substituents are on the same carbon. So it should have been 1-chloro 2,2-dimethyl-propane. Take note of this. I will look at it and get back to you on this, but this is wrong. This is actually wrong. Now we have another set of alkanes called cyclo alkanes. That is, when you have your alkane, I told you when I was teaching you catenation that carbon has ability to form straight chain, branch chain, and cyclic compound. These are the examples of cyclic compound we are talking about. When you have alkane in closed ring like this, look at the structure, it's closed. Because it's closed, you just count the edges: 1, 2, 3, and 3 carbon alkane is prop. So just put in the prefix cyclo. Cyclo means is in ring form, cyclopropane. If you look at this, you count 1, 2, 3, 4. Because it's 4, it's butane, so it's cyclobutane because it's in a ring form. This is pentane, it's 5-sided: cyclopentane, cyclohexane. You can have cycloheptane, cyclooctane, cyclononane, and cyclodecane. So it's as simple as that. But the big one now is this: when you now have a cycloalkane that now have substituents too. For example, look at this. This is normally, without this substituent, is cyclopentane. So because it has a methyl substituent, so you say methyl cyclopentane. Look at the second one. This is a cyclohexane because the ring is 6-sided. Now you can decide to go this way: 1, 2, 3, 4, 5, 6. If you go the way I've just moved, it means your methyl is on carbon 1 and your chlorine is on carbon 3. So look at the first naming. The first naming was considered to be wrong because the numbering was like this: 1, 2, 3, 4, 5. Because we started with this as 1, so it gives chlorine as 1 chloro and the methyl as 5. Because if you go, you have 1, 2, 3, 4, 5. So 1 chloro, 5 methyl cyclohexane. But this is wrong because we could have just moved this way: 1, which gives your chlorine 1 chloro, 2, 3 methyl cyclohexane. So this is better because it gives our substituent lower number. You can see 1 chloro, 3 methyl. while this one gave us 1-chloro-5-methyl. So the way we number in a straight chain alkanes in such a way to give our substituent lowest number is the same way we must go in cyclo alkanes. I hope that is clear. Now this is another cyclic compound. The same thing I just explained. This is a 6 carbon cyclo compound, which is hexane, cyclohexane. So let's deal with the substituent. If you go this way, 1, 2, 3, it means you have 1, 3, because they are the same substituent, 1, 3 dimethyl cyclohexane. But someone else could have gone this way and decide to move this way, 1, 2, 3, 4, 5, 6. That would have given you 1,5 dimethyl cyclohexane. You can see this is wrong because it gives you higher number for your substituent, while this gives you lower number for your substituent. So please put all this into consideration. So I have classwork for you here. Name each of these structure. Name each of these structure. Do this, do everything. Name each of these structure. Just take your time. They are not difficult. They are very simple. Put your alkyl group. If you don't know your alkyl often, go and master it. Methane CH4, methyl CH3, hectane C2H6, ethyl C2H5, propane C3H8, propyl will be what? C3H7. Alkyl is alkane minus 1 hydrogen. So if you are able to do this, you can now move to this. This one is a bit tougher, but I want to believe you'll be able to do it with this explanation I've made, and when you follow the rules, the solution will just fall into place for you. Thank you for listening. Thank you for watching.